The notes for Unit 8, Lesson 4 will cover neutralization reactions. So in this lesson, you'll be able to predict the products for a neutralization reaction. So this is kind of going back to what we did, I think, second trimester. So it will be a little bit of a review, but you will need your yellow periodic table packet because you need, on page 3 of that packet is the periodic table of ions. And that's the chart that has the charges of all the individual ions for the elements and polyatomic ions. So you will definitely need your yellow periodic table with that periodic table of ions out and available so you can see where we're getting these charges from. All right, so neutralization reactions and then titrations, which are the last topic that we'll cover, kind of go hand in hand. So in order to perform a neutralization reaction, you would do a titration. So basically, you have either the acid or the base in the flask at the bottom, and if you have the acid here in the flask, then you would be adding a base to it. And so this is a burette. It's a basically a long, skinny piece of glassware with markings on it. And so that will help you read the volume of how much base you have to add to neutralize the acid or vice versa. So that is what the titration setup looks like. A neutralization reaction occurs when you have an acid and a base, and when an acid and a base react, they produce salt and water. So in this example, you have HCl reacting with NaOH, and so the Cl from the hydrochloric acid and the Na from the NaOH are the two ions that form the salt. Now, we know NaCl is actual table salt. However, the definition of salt for this purpose is any ionic substance. So basically, the salt will consist of a metal and a nonmetal, but it could be any nonmetal or metal combination depending on what acid and what base was mixed together. And then the water, so if you look at the picture, in the HCl you have these hydrogen ions, and then in the NaOH you have the OH minus ions. So if you have H plus and OH minus, if you combine those two, that's where you get your water from. And so those are kind of how the ions rearrange themselves in this chemical reaction. So anytime you have a neutralization reaction, you are going to end up with salt, which is any ionic substance, so an ionic salt, and water. The definition of neutralization reaction is a reaction between an acid and a base to produce an ionic salt and water. And so an example is written below. The acid is nitric acid, which is HNO3. The base is potassium hydroxide, which is KOH. And then what happens is hydrogen has a +1 charge. NO3, remember, is a polyatomic ion, and that has a -1 charge. Potassium has a +1 charge. OH, again, is a polyatomic ion, and it has a negative charge. So this is like a double replacement reaction. So basically, the positive ion from the first element will hook up with and pair with the negative ion from the second compound, and then the other positive ion and the other negative ion will combine. So that's where you get your KNO3. K is +1 and NO3 is -1. And then water, which, like I said, we can also write as HOH. Because those are the two ions that are coming together. So you can write it either way, but just know that you'll, sometimes see it as H2O and sometimes as HOH. Usually it'll be written as H2O, but that's where the H2O comes from, is from the acid-base ions. All right, so here are a few examples, and I think it would be helpful to write these down along with the steps, because you'll have to do some of this in your notebook. So what I would do when you're writing out these equations is I would take your periodic table of ions and I would find the charges of each ion. So hydrogen, for example, is +1. Chloride is -1. Sodium is +1. Hydroxide, like I said, is a polyatomic ion, so that has to stay together, and that is -1. So now we're going to do our double replacement. The positive from one is going to combine with the negative from the other. The positive from the second compound will combine with the negative from the other. So if we have HOH, that would be our water. And then in this case, the ionic salt is going to be the Na, plus the Cl. And remember, when you're writing these formulas, the positive ion always goes first. And anytime you're writing the formulas, you always have to go back to the individual charges to balance out the charges. Because anytime you form a new compound, the ratio of positive and negative ions might change. So if you look at NaCl, Na is +1, Cl is -1, so you would just need one of each. All right, so then there's more. We have to write a balanced equation, so we can't just leave it like this. We have to add our coefficients to make sure that each side of the arrow is now balanced. So if you wanted to write steps down, you could say, that you combine the positive and negative ions for the products. And then you have to balance the charges first. And then you have to balance the number of atoms. With coefficients. So remember, the coefficients are the whole numbers that go out in front of the chemical formula. I'm going to erase my arrows here. All right, so if we look now for step 3 to balance the number of atoms, on the left we have one hydrogen here, and we have another hydrogen here, so that's 2. And on the right we have 2 hydrogens. I'm going to erase those so we don't get them mixed up. All right, so next would be chlorine. We have 1 chlorine on the left, 1 chlorine on the right, so that is fine. And then for sodium, we have 1 sodium on the left, 1 sodium on the right. So this happens to be balanced, so you wouldn't need any coefficients, but if you wanted to, just to have the ratio, each of these would be 1. So like I said, you could leave it blank, or you could add the 1 there, because you will need the balanced equation ratio for our titration calculations, which we'll do next week or in the next lesson. All right, I'm going to erase my steps over here to the right, so make sure you pause it and write those down if you need to. I'm just going to get rid of them to save some space here. All right, so first I'm going to add the charges. Hydrogen is +1. Even though you have 2 ions, you always write just the individual charge. And then SO4 is -2. Potassium is +1, and hydroxide is -1. So if we do our double replacement, the positive will combine with the negative, the positive will combine with the negative. So hydrogen is +1 and OH is -1. So when we rewrite our product, we have to make sure that those charges balance out. So like I said, you could leave it as HOH, or we could change it to H2O. And then the second product is going to be potassium is going to combine with sulfate. So potassium is +1, but SO4 is -2. So we have to add subscripts to balance out those charges. So if potassium is +1 and SO4 is -2, we will need 1 extra potassium, so then our positive charges will equal our negative charges. So we would need 2 potassiums for every 1 sulfate. So remember, when you're balancing the charges, you have to put the little subscript at the bottom. All right, now we get to balance the equation. So I'm going to write the atom inventory underneath here so we can keep track. Hydrogens on the left, we have 2 in sulfuric acid and we have 1 in potassium hydroxide, so we have 3. And then for sulfurs, we have 1 sulfur on the left. Oxygens, we have 4 from the H2SO4 and then 1 from the KOH, so that's 5 total. And then potassiums, we have 1. On the right-hand side, we have 2 hydrogens. We have 5 oxygens. We have 1 sulfur and 2 potassiums. So here's a little hint and trick when you're balancing equations. With this formula, all 4 compounds have hydrogen and all 4 compounds have oxygen. So leave oxygen and hydrogen until the very end. So start with either potassium or sulfur. So if I start with potassium, I have 2 potassiums on the left and I only have 1 on the right. So I'm going to put I have 2 on the right, but I only have 1 on the left. So I'm going to add a 2 in front of the KOH. Now, this gives us 2 oxygens on the KOH and then 4 more here. So that gives us 6 oxygens. And then the 2 also applies to the hydrogen. So we would have 2 hydrogens from KOH, but now we have 2 over here also from the H2SO4, so we would have a total of 4. All right, so now our hydrogens are not balanced and our oxygens are not balanced. Those are the only 2 that aren't balanced. So if we have 4 hydrogens on the left, we are going to need a 2 here because 2 times 2 is 4. And then this gives us 2 oxygens here plus 4 more here would be 6. So now we have a balanced equation. So basically, from our balanced equation, we would need 1 mole of acid for every 2 moles of base. And so basically we would need twice as many moles of base as acid due to this combination of our neutralization reaction. Erase this to give me some more space for the next one. All right, so again, I would add my charges. So hydrogen is +1, phosphate is -3, lithium is +1, and hydroxide is -1. So the H and the OH is going to combine to form my water. And then the salt will be a combination of lithium and potassium. Lithium and phosphate. So again, when you form a new compound, like we just did, we have to go back to the original charges. So lithium is +1 and phosphate is -3. So I need 3 lithiums for every phosphate. Because if lithium is +1 and phosphate is -3, the 3 charges from lithium would add up to +3. And then if we have 1 phosphate, that's -3. And so here now my charges are equal and opposite. So that's why we need 3 lithiums for every 1 potassium. Okay, so now we can balance the number of atoms on each side of the arrow. So if you want to make your inventory, hydrogen, we have 3 here, plus 1 more here is 4. Whoops. Phosphates, we have 1 on the left. Lithiums, we have 1 on the left. And then oxygens, we have 5 on the left. Yikes, my pen isn't working very well. All right, on the right-hand side, we have 2 hydrogens, 5 oxygens, 1 phosphorus, and 3 lithiums. So again, I would keep hydrogen and oxygen until the very, very end. And once you do some of these balancing ones, you'll see a trend. Whoops, change my colors here. So if we have 3 lithiums on the right, I need to put a 3 here. And remember, the 3 applies to the lithium and the oxygen and the hydrogen. So I now have 3 lithiums. Here I have 3 oxygens, but over here I have 4 more, so that's 7. And then I have 3 hydrogens, plus 3 more would be 6 hydrogens. And so now my lithium is balanced. The only thing that's off is hydrogen and oxygen. So then I would balance hydrogen because that's going to be the easiest one. So if I have 6 hydrogens on the left, I need to put a 3 here because 3 times 2 would give me 6. This 3 also applies to the oxygen, so I'd have 3 oxygens here plus 4 more here would be 7. And then now my equation is balanced. So for this equation, for every 1 mole of acid, I would need 3 moles of base. So neutralization reactions are definitely a review from what we did in trimester 2, but remember it's just a double displacement reaction. So you find the charges of your positive and negative ions, and then you switch them. So 2 ions are going to switch places. Remember, for your products, you will always have water and some sort of ionic salt. Whoops. So in this case, gosh, this pen is really not working today. So you'll always have water and some sort of an ionic salt. Whoops. For your products. So let me know what questions you have.